As we have already explained, this is not a course that deals exclusively with data visualization, but data visualization is one of its main components, obviously, because it's so powerful at letting you discover interesting things in your data and then presenting those findings to the public. My own definition of visualization is quite broad. In both of the books that I have written about visualization so far, I define visualization as any graphic that is intended to either communicate or to enable exploration, to let you see let you see things in the data, or enabling some sort of analysis in the data. In this course, we are going to focus mostly on one of the main branches of visualization, data visualization. Now, the whole idea, the main idea behind data visualization is the idea of visual encoding, which is one of the things that we are going to be discussing later on throughout the course. The idea of visual encoding is quite simple to understand. You basically begin with a bunch of numbers with your data set, and then in order to understand those numbers, what you do is to map those numbers onto spatial properties of objects. So you can map, for example, the numbers onto the length of an object, the height of an object, the area, the angle, the width or the height, the thickness, or even shades of color. You can also use shades of color to represent your data. But visual encoding, the most important thing is that it relies on the data, mapping being proportional. That means that whatever numbers you have on your data set, the visual representation of those numbers need to be proportional. The lengths of those objects, the heights of those objects, or the shades of color that you use to represent those objects. In order to show you, to illustrate how powerful visualization can be, I'm going to talk about a very, very simple example. Look, there is a book that I usually recommend to everybody, even if it doesn't have anything to do with data visualization, titled Misbehaving, The Making of Behavioral Economics, written by Professor Richard Thaler. Now, in this book, which as its title says, it's about behavioral economics, Thaler describes an experiment. A while ago, Thaler used to test his students and then score those tests on a scale from 0 to 100, being 0 a total F and a 100 a complete A or an A plus, right? The highest score. And the results was that throughout the semesters, the median score, I believe that it was the median, but I don't remember if it was the mean. In any case, the average score that the students used to get in these tests was 72. And in those semesters, Thaler started receiving bad reviews from his students, or critical reviews from his students. His students were saying, well, Professor Thaler is so hard, he's so tough, his tests are really, really hard, etc., right? So Thaler decided to make an experiment out of this. He decided that from a particular semester on, instead of grading his students on a scale from 0 to 100, he was going to grade his students on a scale from 0 to 137, being 137 an A plus. And the median score, let's say the average score that the students started getting after this change was 96. And Thaler started receiving glaring reviews from his students. His students were extremely happy. But just think about it critically. Is 96 over 137 a better score, a better average score than 72 over 100? Now that I have explained this story to you, probably you will answer that no, that 72 is over 100 is better than 96 over 137. But if I presented this same question to you without telling you the story, I can guarantee that a majority of you will feel tempted to say that 96 is slightly better. And the reason why that happens is that we human beings are really, really bad at dealing with numbers. Numbers are very abstract representation of quantities. We are not very good at that. We are much better at making comparisons when those numbers are mapped onto spatial properties, meaning when we do a data visualization. So here's what I did. I did a data visualization. Take a look at this. When I present this same comparison on a data visualization, right, showing those numbers along common scales, you can clearly see now that 72 is a slightly larger average score than 96 over 137. This is exactly what I mean when I say that data visualization is a means to seeing beyond the numbers, or to letting you see things that you would not be able to see otherwise. Let me show you a real world, a real case scenario. These are records of global temperatures from the year 1000 up to the year 2000. 1000 years of global temperatures in comparison to a mean, or to the 20th century mean, right? So that's the reason why you can see some negative numbers in there. Now, if I present these numbers to you on a data set, like on a table, on a numerical table, it would be impossible for you to see trends and patterns in the data. Unless that you're a very good statistician or a very good data scientist, it would be very hard for you to extract meaning from those data. But take a look at what happens when I map these data onto spatial properties. For example, height or length. All right, when I transform these numbers, for instance, into a line chart, a time series line chart. This is one of the most famous and one of the most persuasive data visualizations ever created. It's commonly called the hockey stick chart, in case you're interested in Googling it. And it was designed by several environmental scientists around 1998 and 1999. And the story that it tells is very, very persuasive, right? Between the year 1000 and the year around 1900 or something like that, global temperatures more or less remained stable. They went up, down, they went up, they went down again, but within a relatively narrow margin. But right after 1900, the 20th century, global temperatures started spiking up extremely quickly. We will not be able to see anything like this kind of pattern, if we didn't represent the data graphically. So this is the reason why in the intro video, and this is just a reminder, I told you that data visualization sometimes is one of the best ways of discovering possible, potential stories in the data. Anyway, I hope that you will enjoy this week. See you soon.